Welcome my students and viewers to my channel. Today in this video I would describe 3 challenging problems, but what is more thrilling in this video is that the solutions of these problems are within a very short and single and one mathematical track, one mathematical identity that is belonging to the triangular numbers. And what is more thrilling is that these 3 problems do not seem to you that they are belonging to one mathematical identity of one mathematical properties of triangular numbers. Though the video takes some long time because of description of the chapters they are related to, this the solutions are related to, that is number system, the base of number system, and the triangular number properties, pattern, and their relation and conversion, so that the junior students can understand and can have a clear idea about the base of the number system. The main mathematical trick, the attacking point, are lying in this change of base of the number system. So I would request you, especially for the learner students, you just watch the video in full up to the end, so that the clear concept of the 2 chapters, that is triangular number and the base of the number system, base system of the number, would be a clear picture. And I think a mere solution of a problem is not a great thing, because we have to learn the skill, so that this by achieving this skill you are to know how to relate the unknown problems to your known mathematical track, right? So that is why I would request you to watch this video in full. So let us come to the try problems. The first problem is, can you make a square with 4 rectangles of 4 centimeter into 15 centimeter each and a square of sides 1 centimeter? Then what would be its sides? That means you have 4 rectangles of size 14 centimeter into 15 centimeter and one square of side 1 centimeter 1 centimeter, and with these 4 rectangles and this small square we have to make a big square. And how did you make this? And if you make this as a square, then what would be the side of that square? That is the question. So the question is apparently on geometry, but you would see that the problem would be solved on the basis of the knowledge of number theory. So then come to the next question. So that for all non-negative integers n, the number 1 plus 9 plus 9 square plus 9 cube plus dot dot plus 9 to the power n would be a triangular number. And I think most of you have already learned what is triangular number. The triangular number is like this. Here are shown the triangular numbers 1, 3, 6, 10, 15, 21, 28, 36, because any number of this sequence can be expressed in the form of triangle, and that is why the numbers are called triangular number. So we have to know the properties and pattern of rectangular numbers. Now come to the third problem. Third problem is also on triangular number. The sums of two consecutive triangular numbers are a square. You have to prove it. Here see the triangular numbers 1, 3. 3 is expressed in a triangle. So these are the triangular numbers because any number can be expressed by a triangle. So these are the triangular numbers 1, 3, 6, 10, 15, 21, 28, 36. All the numbers are triangular numbers. So these numbers are the sequence of triangular numbers. And we have described, we have presented 3 challenging problems, but apparently the last 2 challenging problems are within the triangular numbers, but the past problem is fully on a geometry basis, but that problem is also triangular number. You would see because all these 3 challenging problems would be solved in one mathematical track. That is the thrill of this video today. So now before solving these problems, we would see some concept of triangular number as well as the number system. So before solving this, we would see the number system because we have to have some concept of number system. Okay, so now let us go to the number system. Number system, we usually use numbers in 10 base because generally when we write or speak in number, we usually express this number in 10 base, and the numbers if we express this in proper way, then the number will be written in this way, that is the number within bracket suffix 10. And when the number is, we count the number, the counting natural number as, if we write this number like this way, if we furnish the natural numbers, that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, we know all this. So up to 30 we have furnished here the numbers, but when the same number we write in 9 base, then it can be like this: 1, 2, 3, 4, 5, 6, 7, 8, and see, after 8 the 9 is banished and 10 comes, because here the base system is 9, not 10. And now we can compare the base 10 and base 9. Here base 10 the numbers are shown, and in base 9 the numbers are in red color, and the number in base 10 are in blue color. So you clearly see the number 9 would be actually 10 when base 9, and it is written 9 suffix 10 equivalent to 10 suffix 9. That means the number 9 would be equivalent to 10 when it is written in base 9. So you see that when base is changed, the number from 9 would be 10, 1, 0. Okay, so it is important, and it will be used in the solution of today's challenging problems. and in base 10 the number 10 will be equivalent to 11 in base 9. So it is written 10 suffix 10, that means in the base of 10 the number 10 equal to 11 in base 9, that is 11 within bracket suffix 9. So in this way the numbers are written with the base likely 11 base 10 equal to, when base 9 it will be 12, but when 20, in case of the number 20, what will be the number when base 9, from base 10 to base 9, the number 20 will be 22. Yes, so in this way the number can be changed. If we change the base from 10 to base 9 or base any another number, we can change the base system. So now in this case we have compared only base change to base 10 to base 9. Now we can convert the base from 9 to 10 like this. Actually any number can be expressed in the form of summation of the power of base. Here 1 0 0 is the unit digit, and then the next the next left digit is 1. So 1 0 in base 10 in base 9, that means 10 in base 9 would be expressed in this way: 0 the unit digit plus the next left digit is 1 into the base to the power 1, that is here the base is 9, so 9 to the power 1 is 9. So 1 0 will be expressed as 0 plus 1 into 9 when the base is 9. And in this way when we calculate 0 plus 9 equal to 9, and therefore 9 will be the actual value when it is written in the base 10. That means 10 in base 9 is equivalent to 9 in base 10. So in the same way 11 in base 9 will be expressed in 1 plus 1 into 9, that means 1 plus 9 equal to 10. So 11 in base 9 equal to 10 in base 10. So in this way we see the base can be changed and the number can be changed. 12 will be 11 when the base 9 from base 9 to 10, and 22 when base 9 will be 2 plus 2 into 9, that is 2 plus 9 2s are 18, 18 plus 2 equal to 20. So 20 when the base will be changed to 10. So in this way we can write 9 in base 10 equal to 10 in base 9, 10 in base 10 equal to 11 base 9, and 11 base 10 equal to 12 base 9, and 20 base 9 10 equal to 22 base 9. So in this way we can change the base. But what is the process actually? The process is that any number can be expressed in the form of summation of the power of base with some coefficient of the digit. For example 143, here see 3 is the unit digit, so 143 in base 9 will be expressed in the form of summation of the coefficient into the power of base in this way. Like 143, here 3 is the unit digit number, so 3 plus 3 will come, then plus, then come 4, into the base to the power 1, that is the 9 to the power 1, that is 9, and then come 1 left most digit 1 into 9 to the power 2, because here the base is 9. So in this way the number is expressed in the form of summation of the power of base with the coefficient of the digit number, and therefore 3 plus 4 9s are 36 plus 9 square means 81. So when added we will get 120, and therefore 143 will be 120, the actual value 120, and when the base is 9, then the number 120 will be 143. But you see the change of the base is a system, the number system, and this is the conversion from base 9 to base 10. Just we have written the reverse, then we can convert base 10 to base 9. So here we have shown the change of base from 10 to 9, but you can change the base from 10 to any another number like 8, 4, 3, 2. So see here we see that 9 would be 10 when base changed 10 to 9. So here see 10 base 9 equal to 0 plus 1 into 9, that is 9 plus 0 equal to 9 when its actual value in base 10. So in this way and we can write this in reverse, that is 9 equal to 9 base 10, and then we see 10 base 10 equal to 11 base 9. So first we write 11 base 9, and we can write 11 equal to 1 plus 1 into 9. That means 9 ones are 9 plus 1 equal to 10. So the actual value will be 10 when the base system is 10. And next, if base system 9 when the number is 12, but 11 in number system 10, the number base system 10. So 12 is we know that 12, so we start from 12 base 9, then we can reverse, we can write in reverse way, in this way. 2 here unit digit, so 2 plus 1 into 9, and that is 9 ones are 9 plus 2 equal to 11. So 11 will be the value of 12 in base 9, so 11 in base 10. And now if we know that 20 base 10 equal to 22 base 9, how? Because we can reverse write it 22, here 2 is the unit digit and the left digit, left second left digit is 2, so 2 plus 2 into 9 here will be, and in this way 9 2s are 18 plus 2 equal to 20, and therefore 20 base 10 equal to 22 base 9, that is written 20 base 10 equal to 22 base 9. So in this way we can write the number system from number base 10 to number base 9. But what will be the process, what will be the actual process we can follow from any number when we would want to change its base from 10 to any base? What will be the number? Now here we see a process for the three digit number 120 when base 10 to we want to change its base from 10 to 9, then what will be its value from 120 to what number, then what will be its value? See 120 is divided by the its base we want to change, and here we want to change its base from 10 to 9. So 120 will be divided by, just like long division process. In this way, see, 120 divided by 9, here 9 13s are 117. So 117 subtracted from 120, we will get the remainder 3. Next 13 will again divided by 9 in this way, and then 9 ones are 9 for 13 number, and then from 13 subtract 9, get remainder 4. And see, here the division is complete. So we have got 3, 4 and 1. So now see, 143 will be the actual number. How? See, 3 first. Write 3 plus 4 into 9. Here base is 9 and the division is 9. So 9 plus 1 into 9 square. So this is the 120 number is expressed in the form of power of 9. So the base has been changed from 10 to 9, and clearly the number is what will be the number? The number is 143, because the unit digit is 3, then the left digit will be 4, and then the leftmost digit will be 1. So the number will be 143 when written in base 9. So the number 120 has been changed to 143 when the base 10 has been changed to base 9. So this is the conversion from base 10 to base 9. So you would remember this, and this base system is very much important to know. So now we go to the triangular numbers. What is required, because the problem is on triangular numbers. Now we know the triangular number is originated from the natural numbers actually, and the natural numbers is, we know it, and when the cumulative sum, actually the cumulative sum of natural numbers is the triangular numbers. How? See, up to 1, 0 plus 1 equal to 1, and 0 plus 1 plus 2 equal to 3, and 0 plus 1 plus 2 plus 3 equal to 6. So in this way, 3 plus 3, 6, 6, 6 again, 6 plus 4 equal to 10, up to 5, the cumulative sum will be 15, up to 6, the cumulative sum would be 21. So in this way, the number of cumulative sum, the value of the cumulative sum are all the triangular number. Here the triangular numbers are 1, 3, 6, 10, 15, 21, and 1 is called the first triangular number, that is T1, 3 is the second triangular number, that is T2, 6 is the third triangular number, that is T3. So in this way, T4, T5, T6. So all these are the triangular numbers, and the sequence of the triangular numbers will be like this: 1, 3, 6, 10, 15, 21, 20, 36. So these are the triangular numbers. Now we have to know the properties of triangular numbers. Here the triangular numbers, we have got this, and the nth triangular number will be clearly the cumulative sum of up to the natural number up to n, that is 1 plus 2 plus 3 plus dot dot plus n minus 2 plus n minus 1 plus n, that is C. T1 equal to 1 into 1 plus 1 by 2, T2 equal to 2 into 2 plus 1 by 2, that is equal to 3, and T3 equal to 3 into 3 plus 1 by 2, that is 6, And in this way, T4 equal to 4 into 4 plus 1 by 2, that is 10, and T5 equal to 5 into 5 plus 1 by 2, that is 15, and so on. So in this way, if we find out the value of Tn, so we can obviously find it in its triangular numbers will be n into n plus 1 by 2, and it will be the general form of triangular number. Now we would see the important properties of triangular numbers. See, the triangular numbers, when we would add two consecutive triangular numbers, see, when we would add the two consecutive triangular numbers, what happened? Now let us see 1 plus 3, the first triangular number 1 and the second is 3. So when we will add this 1 plus 3, we will get 4, and 4 is 2 square. So when T2 plus T3, 3 plus 6, that is equal to 9, and 9 equal to 3 square, we know it. So in this way, we see when we add two consecutive triangular numbers, we will get a square number. So here we see like T3 plus T4, T4 plus T5 equal to 10 plus 15 equal to 25. So in this way, it will 5 square. So it is seen that sum of two consecutive number is a square number. But when we see T5 plus T4 is equal to 5 square, we can show it through a picture, and that is why T5 plus T4 is equal to 25. That means 5 square is illustrated through a picture. Now see the picture: a triangle upper side and a lower triangle is drawn, and here are some red colored dots. So you see the red colored dots, the upper triangle is T4, that is 10 dots, and the lower triangle has 15 dots, that is T5. Yes. So when these two triangular number is assembled within these two triangle, then we see here red color number, red color dots, 25, that is because 5 rows and 5 columns of red color dots, so 5 square. And here we can see that T5 plus T4 equal to 5 square, and how it is made we can see it through picture. So here clearly we see that sum of two consecutive triangular numbers is a square, but we have to prove it for any general two consecutive triangular numbers. To generalize the proof, we have to take the general triangular number Tn, and before that the nth, that is n minus 1th triangular number, that is Tn minus 1. So Tn minus 1 plus Tn equal to, that is we know that Tn equal to n into n plus 1 by 2. So Tn minus 1 equal to, in place of n we have to put n minus 1. So n minus 1 into n minus 1 plus 1 plus by 2 plus n into n plus 1 by 2, and therefore we will get 2n square by 2 and then n square. So after simplifying this, we will get n square. So now we see that for any two consecutive triangular numbers, when we add this, we will get a square number, that is here n square, a square number. So we come to this decision that sum of any two consecutive numbers is always square number. So it is also proved, a problem was that we have to prove this. So we have proved this. So problem number 3 is proved. Now again we go ahead for triangular numbers. See the triangular numbers 1, 3, 6, 10, 15, 20. So now see a feature like 8 into a triangular number plus 1. What happened? So now, okay, 8 into the first triangular number plus 1. What will be its value? Its value equal to 8 into 1 equal to 8 plus 1 equal to 9. So 9, and 9 is 3 square. So we have got 3 square, that is an odd square. And next we will take the second triangular number, that is 3. Just we will find the value of 8 into a triangular number and add 1 plus 1. So next we take for the second triangular number 3. So 8 into 3 plus 1. What will be its value? Let us see. Its value will be 3 8s are 24 plus 1 equal to 25, that is 5 square. Again odd number square. And let us take the third triangular number, that is 6. 8 into 6 plus 1. What will be its value? 48 plus 1 equal to 49, that is also another odd number square. And next 10 we may take with the fourth triangular number, that is 10. 8 into 10 plus 1. What will be its value? Its value 8 tens are 80 plus 1 equal to 81. That is also another square number of odd number square. So a very nice pattern is seen here, isn't it? The 8 into a triangular number plus 1 will be an odd number square. So we can see this nice pattern and properties of the triangular number. So this is very important because using these features many new problems will be solved. So today's challenging problem will be solved using this attractive pattern of the triangular numbers. But why this pattern is true? Because we would see by calculating 8 into Tn plus 1, we can take any generalized triangular number, that is Tn. We can put the value of Tn, that is nth triangular number, that is n into n plus 1 by 2. So 8 into n into n plus 1 by 2 plus 1, we can value it, we can simplify this. 4 into 80, 4n square plus 4n plus 1, and that is clearly 2n square plus 2 into 2n into 1 plus 1 square. So it is also a square, 2n plus 1 whole square. So it is purely an odd number square, because for any negative, any positive integer of the value of n, 2n plus 1 will be odd number. So 2n plus 1 whole square will be an odd number square. So we see that any triangular number when multiplied by 8 and added with 1, then we will get an odd number square. So it is an important feature of triangular numbers. You would remember these features. Now this identity is expressed in a geometrical figure. Now see here 8 copies of triangular numbers, that is n into n plus 1 by 2. 8 into n into n plus 1 by 2 means 8 copies of triangular number. So we can express it that equivalent to 4 into n into n plus 1, when 8 divided by 2 will give 4. So 4 into n into n plus 1. Here 4 rectangles, if we imagine 4 rectangles of n into n plus 1, here we have drawn the 4 rectangles of sides n into n plus 1 in this way, and we have stacked these 4 rectangles in this way. 4 rectangles having size n into n plus 1, and if we stack these 4 rectangles in such a way that a vacant square is left in the center of shape 1. So see the figure in the right side. Here are a big square of having every side n plus 1, that is 2n plus 1, and that is the square is formed by 4 rectangles of each n into n plus 1. The rectangle sides are n into n plus 1. So we have got 4 rectangles, and we have got this square of size, every side has n plus n plus 1, that is 2n plus 1. So the square having side 2n plus 1. Clear? So now if you put the value n equal to 14 centimeter, n equal to 14, then you will get the question and solution of the problem, the first problem. That is, you have to make a square with 4 rectangles of size 14 into 15 centimeter and a square 1 centimeter. So here clearly we see that when we put n equal to 14, then the square will be 2 into 14 plus 1, 2 into 14 plus 1, that is 2n plus 1. So the size of the square, the side, every side, the length of this, every side of the square will be 29 centimeter, and therefore 29 centimeter into 29 centimeter will be the sides of the square, and you will get the answer of the question number 1, the problem number 1. So you see that by knowing the features of the triangular numbers, that a triangular number when multiplied by 8 and added by 1 will be a odd number square. With these features we can solve this problem. Now another use of this problem, another use of this feature would solve the next challenging problem. See, this 8 into tn plus 1 equal to 2n plus 1 square. That means a triangular number when multiplied by 8 and add 1 will come to a number that is an odd number square. Is it true that the converse statement of this statement? Yes. Means when for any odd number square, we will get a triangular number. Suppose 2n plus 1 whole square equal to x. Suppose its value is x. So x minus 1 by 8 will be the tn, that means the triangular number. So the x minus 1 by 8 will be triangular number. This statement is also true. Now we can prove this. For any odd square x, always x minus 1 by 8 will be tn, that means a triangular number. Suppose we can take x equal to an odd number square like 25, because it is 5 square, so x equal to 25. So 25 minus 1 by 8, what will be? 25 minus 1 by 8 equal to 3. Is it a triangular number? Yes, 3 is a triangular number. So it is true, 3 is a triangular number, that is second triangular number. 1 3 6, so 3 is the second triangular number, that is T2. And for x equal to another, we will take another odd number square. Suppose x equal to 169, then what will be the value of x minus 1 by 8?
Is it a triangular number? Let us see. 169 minus 1 by that is equal to 168 by 8, that is equal to 21. Is 21 a triangular number? Yes, 29 is also a triangular number because it is sixth triangular number. You would see that sixth triangular number will be 21. So for the odd number 13 square, that is 169, we get a triangular number 21. And now we may prove that for any general odd number square we will get a triangular number. We have to prove this. Now we have to take a general form of odd number square. What is that general form of odd number square? That is, we can take 2n plus 1 is a genuine odd number. So 2n plus 1 whole square will be a genuine odd number square, because here for any positive integer value of n, 2n plus 1 will be purely odd number, and then 2n plus 1 whole square will be an odd number square. So now let us examine that whether 2n plus 1 whole square, taking this we can see x minus 1 by 8, that is 2n plus 1 whole square minus 1 by 8 will be whether a triangular number or not. Now let us examine. So here 2n plus 1 whole square equal to 4n square plus 4n plus 1, and then x minus 1 by 8, that means 4n square plus 4n plus 1 minus 1 divided by 8 equal to, we may calculate it, then 1 vanished, and 4 and 8 are will give 2 in the denominator, and we will get n into n plus 1 by 2. So clearly it is the nth triangular number, that is n into n plus 1 by 2. It is nth triangular number. So purely we will get this triangular number from the odd number 2n plus 1 the whole square. So now we would come to the decision that for any odd number square we will get a triangular number. We must get a triangular number. So this is a very important feature of triangular number. So using this triangular number feature we will solve many challenging problems. So today's the most challenging problem, that is the 1 plus 9 plus 9 square plus 9 cube plus dot dot up to 9 to the power n. We have to prove that the summation of this given expression, that is 1 plus 9 plus 9 square plus 9 cube plus dot dot up to 9 to the power n, will be a triangular number. Observe, 1 is a triangular number, 1 plus 9, 10 is also a triangular number, and 1 plus 9 square, that is 91, is also a triangular number, that is the 13th, or that is 13th triangular number. So we would see that if up to 1 plus 9 square, and if we take 1 plus 9 square plus 9 cube, that is for n equal to 3, 1 plus 9 square plus 9 cube, that is if we calculate we will get 820. And is it 820 a triangular number? Yes, 820 is also a triangular number, that is 40th triangular number. If you will write the sequence of triangular numbers up to 40, then you will get that 40th triangular numbers will be 820. So the value of the summation up to n equal to 3, we see that the number is a triangular number, but we have to prove this for any finite value of n. The number 1 plus 9 square plus 9 cube plus dot dot up to 9 to the power n will be the triangular number. We have to prove this. So to prove this, just you have to remind the base system. Here you would need to use the change of base. So now you will just remind the base system. Here the number 9, when base will be changed from 10 to 9, then the number 9 will be 10. See, the 9 will be equivalent to 10, that means 10, when the base change from 10 to 9, and the number 10 will be equivalent to 11 when the base will be 9 from 10, that is 10 when base 10 equal to 11 base 9. So only these two things will be used and we will solve this problem. The rest of the number system is not here used, but you have to have the knowledge of the number system. So let us come to the problem again. We know that for any odd square, x minus 1 by 8 will be a triangular number, and a triangular number when multiplied by 8 and plus 1, that is add 1, then it will be a odd square. So now actually we have been given here a number p equal to, suppose p equal to 1 plus 9 plus 9 square plus 9 cube plus dot dot up to n9 to the power n. So we have to actually see that this number is a triangular number. How will I show that this number is a triangular number? How it is proved? Actually it is proved in this way, that 8 into this number plus 1 will be whether that is a odd, that is an odd number or not. If that value will be expressed in the form of an odd number, then we can easily say that this number is a triangular number. So that is the strategy to prove this problem. So now let us see. So now first change the base from 10 to 9. We know that the number 9 would be actually 10 when the base has been changed from 10 to 9, because we know 9 would be 10 when the base will be 9, and therefore in place of 9 we write 10. Just replace 9 by 10 and then we will get 1 plus 10 plus 10 square plus 10 to the power n, and within bracket base suffix 9. That means all the numbers are written in base 9. Here when 1 is added with 10 we will get 1 1, and then when 1 1 will be added with 10 square, that means 100, then we will get 1 1 1, and when 1 1 1 will be added to 10 cube, that means 1000, then we will get 1 1 1 1. So in this way when we will add this the sequence, then we will get the number 1 1 1 1 1 1 up to all the numbers will be 1, and here we will get nth number of 1 we will get. So we have this number 1 1 1 1 dot dot when the base is 9, so within bracket 9. And now let us take whether 8 into this number plus 1, that is 8p plus 1. Why 8p plus 1? Because we know that a triangular number when multiplied by 8 and added by 1, and if this number is an odd number square, then we will say that the number is a triangular number, because it is then an important features of the triangular number. We have shown it previously. And now 8p plus 1. 8p plus 1 would be here 8 into 1 1 1 1 dot dot 1 suffix 9 plus 1 and when 1 is multiplied by 8, that will be 8, because in base 10 and in base 9, 8, the number 8 will not be changed. So we will get 8888 base 9 plus 1. And when 8 is added with 1, then in base 9, clearly you know that 1 0 will come, because after 8 comes 1 0. So we'll get 1 0, then 1 will be added to next left 8, and then we will get 1 0, and then 1 will be added to next left 8, and in this way we will get 1 0 0 0 0 0 0 up to all numbers will be converted to 1 0 0 0 0 when the base will be 9. So suffix 9, and because 8 base 9 plus 1 equal to 1 0, that is 10. So here the number will be 1 0 0, and you clearly see, it is obviously seen that 1 0 0 0 is a power of 1 0, that is a power of 10, isn't it? So it is clearly a power of 10 when base 9, and 10 is base 9 when, and if we convert again the base 9 to base 10, then what will be its value? The 10, the number 10 will be changed to 9, because 10, the 9, actually 9, the number 9 is in base 9 will be 10. So the when the base 9 will be changed to base 10, the number 10 will be 9, 9 base 10, and 9 base 10 means actually the number 9, and 9 is 3 square, an odd number square. So the whole number will be, and 9 itself is a 3 square, an odd number square. So the power of 9, that means 100, that means 8p plus 1 is an odd number square. So 8p plus 1 is an odd number square. So it is obviously, we can come to the decision that p is a triangular number. That means the given expression 1 plus 9 plus 9 square plus 9 cube plus 9 dot dot 9 to the power n will be a triangular number. So the problem is solved. The challenging problem is solved in this way. If you get interest, like and subscribe the channel for more such interesting problems and solution, and you can also comment in the comment box, and thank you for watching.